Hello students, welcome back. In this video we are going to go through Chapter 1, Section 3, Collecting Sample Data. In the previous video we talked about different types of data. Now we are going to talk about how we're going to sample it. And the key concept here is the method used to collect data influences the quality of the analysis. If you collect good data, you'll get good quality results. And if the sample data is not collected in an appropriate way, it's going to be so useless that no matter what you try and do to the data, you can't salvage it. Bad data cannot be used, no matter what you do to it. So what we call the gold standard is the best method, the most effective way of getting good data. And that's going to be randomization with placebo treatment groups is probably the best way you can do it, like giving one group a pill and then another group a sugar pill, and then looking at the random results based on it. That would be the best one, is a simple random sample. So there are two distinct sources of these methods. They're going to be observational studies and experiments. Experiments apply some treatment and then proceed to observe its effect on the individuals. So the individuals are going to be called the experimental units, and they are called the test subjects, pretty much. You're going to apply a treatment to them and then pretty much wait around and see what happens. Observational studies is we are observing and measuring characteristics without attempting to modify the individuals being studied. It's basically trying to be a fly on the wall and watching how people react without being prompted to do so in a certain way. So let's look at an example. Ice cream and drownings. So observe past data to conclude that ice cream causes drownings. Okay, how would ice cream cause drownings? Well, based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature, and the failure to see that as temperature increases, ice cream sales increase and drownings increase before more people swim. So what we mean by that is this is a whole correlation and causation dilemma. One might look at data and it is true. The more ice cream sales that occur, the more drownings that occur. So you might think, oh, they are cause and effect. They're related. Well, there's definitely a correlation, but they're not causation. Ice cream is not causing more drownings. Increased ice cream sales is probably the result of warmer temperatures. The warmer the temperature, the more likely you are to swim. The more likely you are to swim, the higher chance of drowning. So they are correlated, but not cause and effect. That would be the observation, is looking at that from a distance. An experiment would be conducting an experiment with one group treated with ice cream, and then the other group gets no ice cream. Aw, poor them. So we would see that the rate of drowning victims is about the same in both groups. So then we would be able to dismiss the claim that they are cause and effect. So here, the experiment is clearly better than the observation study, because if one group had ice cream, the other does not, and then you throw them in a pool, well, you expect their drowning rates to be the same. Pretty morbid experiment, but I think you get the idea. So when we design experiments, let's talk about that. Replication is the repetition of an experiment on more than one individual. So good use of replication requires sample sizes that are large enough that we can see effects on treatment. You can't give a pill to 2 people and then say, oh, look, both of them are cured, so 100% of people are going to be happy and satisfied with this effective treatment. No, you can't really do that. Blinding. Blinding is a technique in which the subject doesn't know whether he or she is receiving a treatment or a placebo. This is pretty good. Because this is a way to get around the placebo effect. So I have 100 people with, I don't know, a headache, and then I give 50 of you ibuprofen, and then 50 of you an M&M that looks like ibuprofen. You both take it. I ask you 20 minutes later, how do you feel? You don't know if you took a pill or sugar, so you are honest with your answers. You don't have a placebo effect. You answer honestly and non-objectively, and we see the results. That's a blind experiment. Now we even have an even better type of experiment, and that's the double-blind experiment. So this is different from a regular blind in that, number one, the subject doesn't know whether he or she is receiving the treatment of a placebo, but also the experimenter doesn't know whether I'm administering the placebo to you. So you don't know if you took the M&M or the ibuprofen, and the person giving you the pill doesn't know. So now you have 2 levels of blind experimentation. Of course, there's a way for you to actually figure out in the end, but you don't want to have any preconceived notions based on knowing whether or not they took the pill or the M&M. Finally, randomization is used when subjects are assigned to different groups through a process of random selection. And the logic here is that when you do randomization, you get groups that are similar, and there's no false grouping of any kind. So simple random sample is the type that we really are striving for. Simple random sample is you have a sample of n subjects are selected in a way that every possible sample of the same size n has the same chance of being chosen. A very wordy way to say it, but just think of choosing a name out of a hat. You or little Timmy next to you have the same chances of having your name pulled out of that hat. It's simple, it's random, it's good data collection. Systematic sampling is you select some starting point and then every kth element in the population you choose. So you have people in a line, and then I'm saying I'm going to choose every third person. So the third person, the sixth person, the ninth person, the 12th person come with me, and I'm going to sample you guys to do my test on. That would be systematic. Convenient sampling is use data that are very easy to get. So maybe I'm posting survey questions on my Facebook page using SurveyMonkey or something. It's convenient because I don't have to really go out of my element to get them. People are reporting their information to me. It's convenient. It's easy to get to. Clearly, this is opening the door for many forms of bias. Maybe if I'm asking about how many hours of TV do you, or how many hours of sports do you spend a week watching on TV? If my friends, I befriended them because we all played hockey together, well, that's going to be a source of bias because I'm likely to have friends who watch more sports than the average person. And that's an error of the convenience sampling, is that I'm likely going to ask questions to people who are likely to overrepresent a certain population. Maybe you're friends with a certain political group. So if you ask a question about politics, you're likely going to have results that overrepresent the views that you have, since you're likely to be friends with people who have a certain view. Stratified sampling is you subdivide the population into at least 2 different groups, think men and women, and the subjects within the same group share the same characteristics. And then we're going to draw a sample from each subgroup. So you separate the room, guys and girls, and then select certain ones within each subgroup. Finally, cluster sampling is we are dividing the population into sections or clusters, and then randomly select some of those clusters and then choose all members of those selected clusters. So maybe I want to know how people are going to be voting in a little town's mayor election. So I'm going to randomly select different blocks, these little red rectangles, randomly select those clusters, and then I'm going to interview every single member on that block. Multi-stage sampling is collect data by using some combination of the aforementioned sampling methods. And then you just try and use more than one at the same time. Observational studies is observe and measure, but do not modify them. It's kind of a randomly thrown in slide. Okay, types of observational studies. So now we're doing observational studies. So let's do a cross-sectional study. A cross-sectional study is that data is observed, measured, and collected at one point in time, not over a period. Retrospective or case study is that you are looking at data from a past time, and you're going back and then looking through them to make your conclusions from them. And then Perspective is data is collected in the future from groups sharing common factors. So cross-sectional is pretty much current, retrospective is past, perspective is future. Sampling errors. So no matter how well you plan and execute the sample and collection process, there is always going to be some form of error. So sampling error occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result. Like, you're never going to get 100%. You interview 1,000 people to see how many people are going to be voting a certain way. When the actual polls come from when the actual vote results come from the election day, your polls are never, ever, ever going to be 100% accurate. There's always going to be some form of sampling error. And that's because maybe there's an error in the way you collected the data, but human nature is impossible to fully predict. Non-sampling error is the result of human error, including factors such as wrong data entry, computing, questions of biased wording, false data. Basically, there is a human that pretty much messed it up, or intentionally or unintentionally caused there to be a discrepancy in the sample results versus what the true population results would suggest. Non-random sampling error is the result of using sampling method that is not random. So convenience sample, I talked about before, is going to be errors because of overrepresenting or underrepresenting a certain group. Voluntary response sample, people are going to be lying about their results. So you're going to get non-random sampling errors that way. And that concludes Chapter 1. Any questions, as always, feel free to email me or shoot me a text on my Google Voice. Thank you, and see you in Chapter 2.